All right. Hello, everyone, and welcome to the latest edition of Scrubbing the Skies, the webinar series of the Institute for Carbon Removal, Law and Policy at American University. I'm Wil Burns, and I'm founding co-director of the Institute. One of the most imposing challenges that the nascent carbon dioxide removal industry, as well as society, faces is what to do with what ultimately may be hundreds of gigatons of carbon captured in facilities such as direct air capture and bioenergy capture with storage installations. There's trepidation about whether adequate and safe space will ultimately be available for this purpose and whether public opposition might grow as such operations scale up. Also, many believe that potential valuable uses of captured carbon might help to bolster the business case for carbon removal. In recent years, a number of companies have emerged in what has become to be known as the carbon capture and utilization, or carbon capture and transformation sector. While many of these companies are currently focused on uses of carbon captured at point sources, these technologies have obvious and clear implications for the future of the carbon dioxide removal sector also. So I thought it'd be helpful to discuss the current state of play in this sector as well as its potential future. To help me do so, I'm pleased to welcome today Tom Dower as my guest. Tom serves as Vice President for Public Policy with LanzaTech, a company that transforms waste carbon into materials such as fuels, fabrics, and packaging. LanzaTech, which is based in Skokie, Illinois, the town next to where I live, was recently named to Fast Company's World Most Innovative Companies for 2023. It was also named as a finalist for the Earthshot Prize in 2022, and it is also the first carbon capture and transformation company to go public, which it did in February of this year, and it's listed now on the NASDAQ. As a brief additional introduction of Tom, he has over 25 years of experience in Washington, D.C. in the government and industry sector, specializing in energy and climate policy, including 15 years in the U.S. Senate as a staffer for former Senator Arlen Specter and as a climate advisor to former Senator Jay Rockefeller. He was also vice president for the Lighthouse Consulting Group, representing the U.S. Climate Action Partnership and energy sector clients during the 2008-2009 Waxman-Markey process. And he's a proud graduate of American University. Tom will initially provide a brief overview of LanzaTech's approach in the context of carbon capture and transformation. I'll follow up with a few questions to seed the conversation, and then I'll open it up to our audience. So feel free to start populating the chat box with your queries and your comments. And with that, Tom, the floor is yours.
Thank you. Thanks so much, Will. I really appreciate it. Appreciate being here and the invitation. I will pull up my slides. And as you mentioned, I have been working on environment, energy, and climate policy for quite a while now, and have honestly decided to devote my life to tackling climate change. So that's why I was so pleased to receive this invitation. And in doing so, I tend to veer towards the difficult. Tried to pass cap and trade bills through Congress. Worked for moderate Republican and moderate Democrat senators from manufacturing and fossil fuel states, and worked for the world's largest steel company, pushing the industry on greenhouse gas mitigation, and now working with a biotech company going after hard to abate sectors, but in a novel way. So I love a challenge, and I'm very glad to join everybody here today. This is our standard but important disclaimer about forward-looking statements. We're now a publicly traded company, as Will mentioned, and so I just want to be careful about what people take away from these conversations. So what is LanzaTech all about? We were founded in 2005 in New Zealand, and over time, LanzaTech has moved to the US. So now we're a US-based company. And as noted, as of February, we're now a publicly traded company on the NASDAQ, the first carbon capture and transformation company so listed. We really sit at the intersection of science, engineering, data analytics, artificial intelligence, and ultimately reducing carbon emissions. That's the reason we exist. And LanzaTech captures and transforms carbon. We do this by using waste in its many forms. And we do that by transforming those wastes into essential chemicals, fuels, and products that still need carbon as their central molecule, even after we reach what we would call the decarbonized, or as we say, the post-pollution future. So before diving into our technology, I did want to start with a few things that we fully stipulate. First, as many processes and sectors as possible should be electrified, and the power sector itself must be decarbonized as soon as possible. We must also insist on material and energy efficiency, less waste, more recycling. But many fuels, chemicals, and products will still require carbon. We are in a critical time period where massive emissions reductions are essential to avoid some of the worst impacts of climate change. We saw the recent IPCC report, which I won't get into in detail, but it's getting worse and worse, and the challenge is getting larger. And so to meet that moment, we're going to need carbon abatement, carbon removals, adaptation. I mean, they're all crucial pieces of the puzzle. Fortunately, there are technologies that can reduce emissions today and transition to an emissions-free economy in the future, and ultimately get to net negative emissions. So let me show you how LanzaTech converts wastes into useful, sustainable products. We do this through biology and what is known as gas fermentation. So at the heart of our process is biology, specifically a biocatalyst that is centered around bacteria, which wants to consume carbon monoxide, carbon dioxide, and hydrogen in the form of gases. So this is actually a continuous process, so much more like a traditional manufacturing process than the batch type process that one would typically see used to make alcohol from sugar and yeast, for example. In this case, we feed carbon and energy to bacteria. Let me walk through the feedstocks a bit and then the products. So as mentioned, we have really started with industrial off gases. So this is traditional carbon capture, but we can send those gases mostly in their current form. We do a little bit of gas cleanup and a little bit of compression, but our process is operating at near ambient temperatures and pressures because we're dealing with biology here. So this is not high temperature, high pressure environment that you would see with thermal catalysts. And industrial off gases are what we started with. That's what our founder, Dr. Sean Simpson, looked at in New Zealand, looking at steel mill off gases in particular, and found that they are really the perfect food for this bacteria that we use. But beyond industrial off gases, we can also look at agricultural and forestry residues, municipal solid waste, non-recyclable waste, et cetera. And those can be gasified and then sent through that same process. And then ultimately, really going to the future when many of these wastes will actually hopefully go away over time. We can use electrolysis, direct air capture for CO2, use clean hydrogen, and feed all of those into the same process, same equipment, but you can essentially change the feedstocks over time. You can transition with the economy, et cetera. And I'll get a little bit into sort of our concept of hardware and software a little later about both the feedstocks that we get and the products. So on the product side, through this fermentation, we get lower carbon ethanol, which is an energy carrier and can be converted into sustainable aviation fuel, into cleaners, detergents, a huge range of products from polyester to plastic, fabrics, et cetera. And most importantly, those are all products that today come from virgin fossil fuels with all of the attendant consequences, including and beyond greenhouse gas emissions. And as I'll discuss a little later, instead of ethanol, we can also produce other targeted chemicals through advanced synthetic biology for which LanzaTech defines the cutting edge. And then all of this can be circular. So that's a really important message for today, is the kind of carbon utilization we're talking about is converting above ground waste carbon into the products that society still needs and will still need in 2050, 2100 and beyond. But in some cases, those impacts those products, I should say, will still have emissions associated with them, or they will still end up as wastes. So we want to turn that into the circular economy, where those wastes can be reused for the things that society still needs. So on net, they have no net impact, or ultimately, if we could get to negative, when we combine that with CDR technologies. So as I mentioned, the first version of our gas fermentation process makes ethanol as the product that comes out of the process, but not necessarily with the intention of using it as a gasoline additive, for example, which is how most of us think about ethanol in the modern world. But really, it's actually a building block for other fuels, chemicals, and products. And so you can see on the left side here, that means fuels like complex carbon chains that are necessary, these complex hydrocarbons for transportation fuels, particularly aviation, which needs highly energy dense liquid transportation for now and well into the future. And then on the right side, we've also been able to show these pathways to polyethylene, MEG, PET, EVA, for the soles of your shoes, for example, for sneakers and other things. And this is not theoretical. This is not just on a piece of paper. These are real things. These are real products, used across many different sectors. Everything you see here on this slide was made from recycled steel mill emissions that were turned into ethanol, which were then converted down supply chains to all of these really interesting products. And with a lot of consumer-facing brands that have made a lot of commitments about what they want to do with their supply chains and reducing their emissions. But as I mentioned earlier, not everything can be mechanically recycled, and so you're going to have something else in the system. And that's where our gasification comes in, where you can recycle as much of those end products that are recyclable, but lots of things are not, and they will end up in the trash stream. And so we need to have something else. So we've been working on a lot of projects with some of our customers and our partners to really show the highest best use of these recycled materials. Again, this is not science fiction or anything. This is very real, and we are really intending to help decarbonize multiple hard to abate sectors all around the world. Sometimes multiple sectors at the same time with the same project. So imagine capturing carbon emissions from a steel mill, for example, and converting them into sustainable aviation fuel, chemicals and products, all of those things, all in different sectors. But today, all of those products are coming from virgin fossil fuels. So we have projects all over the world using diverse feedstocks and using the flexibility that's inherent in our biology-based process. Here are some examples of what our commercial facilities look like to just kind of give you a visual. There's it's really compared to the facilities in the industrial case, for example, our facilities are rather small compared to the humongous steel mills and refineries and others, but there's still industrial applications, right? So these do have a footprint, but fortunately, lower energy penalty than a lot of technologies, lower water usage, et cetera. So this is what it looks like in the real world. And I mentioned earlier this concept of hardware and software. So the question that we ask as we're working with partners, and we have today a licensing technology. We may move beyond that into build, own, operate, or work with other funders to build facilities. But currently, we're working with facilities that have carbon emissions, and they want to reduce them. So we work with them to install the hardware, which is to put essentially a biorefinery on the back end of their industrial facilities. As we do that, we obviously capture their off gases. We convert those through bacteria to ethanol or these other products, and sell those into the market. And so it's one of the few options that actually does have a potential revenue stream. Granted, these are nascent markets, so it's not always quite as clear as oil, for example, where you can Google the price of oil and find out what it is this minute. Not quite the same for low carbon products. But once you've built this system, what makes it really interesting with biology is that we can change the software. So the particular version of the bacteria that is in this biocatalyst can be changed. And so instead of making ethanol, we can choose one that makes isopropanol or acetone or MEG, which then go down specific pathways. So again, it's the same CapEx, it's the same facilities, the same reactors, but you may need to make slight modifications, but otherwise you're really just scrubbing the bioreactor and filling it with a new version, which is really interesting, and really only biology can do that. In petrochemical world, you'd have to build a very specific unit to do a specific thing. And so that allows us through synthetic biology to really work with industries that have that are hard to abate. They have real challenges for reducing their emissions, and so we can work with them directly. So we work with the chemicals sector. So many different chemicals. We've proven in the lab already that we can make over 100 different chemicals. That number will continue to rise as we work through our biological processes and engineering. We can also go into different materials, natural rubber, for example, substitutes, because it is very difficult to recycle rubber, for example, from tires. So we're working with partners on that. Packaging, as Will mentioned as well, working with Danone and other partners to get at some of those harder to recycle packages and harder to create sustainably in the beginning. Fragrances, we just had an announcement this week with Coty, who is a global fragrance producer, and a new Gucci line, for example. And then fabrics, we have Lululemon, we have Zara dresses, you name it. They need to decarbonize these supply chains. And one thing I have found really interesting just in my time at LanzaTech is that so much comes from virgin fossil fuels today that we don't even know. We go to the store and we buy things, and some of us are more informed than others about where food and materials come from, but even those of us working in the field sometimes don't realize these complex fossil-based supply chains. The other thing I want to talk about a bit is sustainable aviation fuel. This is another really interesting and really important aspect of what we do, because if we can take waste carbon and convert it into aviation fuel, that provides one of the only chances that the aviation sector, which is growing due to growing population growth and the desire of people around the world to move, we can produce now aviation fuel from any kind of ethanol. And we worked with the Department of Energy on this for over 11 years to bring this to market, and also spun out a company called LanzaJet, which is currently building the first alcohol-to-jet facility using this technology in Georgia in the US, a 10 million gallon per year facility that makes essentially 9 million gallons of sustainable aviation fuel and 1 million gallons of renewable diesel. So really targeted towards the hardest to abate sectors that don't have any other or that many other options. And so in sum, we are taking every waste resource, including carbon dioxide, through carbon dioxide removals, direct air capture, to make everything that we need, all the things in our lives. And we ask, consumers and everyone else, where does your carbon come from? That ultimately is going to be the question. And then just a couple final thoughts. As we're pursuing policy, we prefer tech-neutral, performance-based policies, which set the societal goals, but really drive innovation to meet them. And too often we're confronting around the world, the old adage of making the perfect the enemy of the good, or even the great. And that recycling carbon is much better than extracting and refining more virgin fossil fuels. So really wanted to make that point today, and we can get into that more in the discussion. But there are going to be massive capital turnover challenges in a lot of sectors. So we really have to look at this sector by sector, product by product, and we can't be waiting for the perfect solutions while allowing highly emitting sectors and industries to just pump greenhouse gases into the atmosphere unabated, which puts further pressure on the already huge goals of carbon dioxide removal, and essentially is allowing million or hundreds of thousands of parts per million emissions into the atmosphere, and then having to go back and get them at 400 plus parts per million. So it's sort of illogical to allow that to happen, and it's inefficient, and it really puts too many eggs in one basket, especially in this critical decade. So someday in my lifetime, I'm hoping to present this slide, welcome to the post-pollution future, but in the past tense, where we've already established that post-pollution future. Thanks, Will. I'll stop there and open it up for questions.
All right. Thanks so much, Tom. Okay, let me just ask you a few initial questions, and then we've got plenty of good questions as usual from the audience to work through. I guess one question is, and this riffs a bit off of your comment about not letting the perfect be the enemy of the good. One of the knocks on carbon capture and utilization especially for products such as fuels, is that the carbon sequestration that's ultimately effectuated is pretty ephemeral, right? How would you respond to that criticism that it's not actually, reducing carbon emissions or atmospheric levels of carbon dioxide?
Yeah, thanks, Will. A great one, and that is certainly one we do hear. Well, first, I'd say at the highest level that first of all, fuels in and of themselves are intended to meet a societal need, right? So the question is, how do you get those fuels? They're not at first blush a carbon sequestration opportunity because, like you said, those are quickly used products in society, right? But that said, not all fuels are the same. And really, you need to conduct a robust LCA. I should have mentioned this already in my talk. Life cycle analysis is so important to considering these things and really trying as best you can to get them on a level playing field. And for us, the fuels for hard to abate sectors are more about the displacement of fossil fuels. And if we never replace those fossil supply chains, the virgin fossil fuels will live longer than they would otherwise, right? So I like to say there's nothing more permanent than leaving fossil fuels in the ground. And so for us, that's sort of the first test, and really going after hard to abate sectors. Back to what I said, fairly early on in my talk, we do agree we should electrify everything we can, right? So if we can electrify the light duty vehicle fleet, for example, that will just reduce the amount of liquid fuels needed. But you still have the conundrum of aviation, long haul trucking, maritime, right? So those are big fuel users, and lots of debate about what the right answer is to those questions and whether power can be used for some of those applications. But in others, it's really about converting energy into some sort of a liquid transportation fuel. So then again, you're back into need to do it robustly through life cycle analysis and making sure you're minimizing, if not eventually getting to negative emissions for those sectors, because the need will not go away, right? We're not going to stop moving ourselves and things around the planet.
In these hard to abate sectors, do you think there's any danger that that carbon capture and utilization could potentially throw a lifeline to these sectors and deter them from actually abating when they could, because there's this potential get out of jail card, right, of handing it over to a company like Lanza? What would you say to that? Because we obviously hear that a lot.
Yeah, that's the moral hazard question, right? Yeah, absolutely. So first I'd say, and I wish I had a slide that showed again what I tried to describe, which was like the size of the LanzaTech technology on the back end of a humongous industrial facility, right? I would say, in addition, it's about the cost, right? These are hundreds of millions of dollar sort of abatement options on billions of dollars of assets. So it's to me, it's a bit of the tail on the dog that these industries are going to make decisions based on the best economics for them. And we can help with those emissions, but we're also here to be a transition source. We are not targeting sectors in order to keep them alive longer. We are targeting sectors that have difficulty abating their emissions and will continue to have difficulty for quite some time, so that we can reduce those emissions as they transition, going in fully eyes wide open. And certainly, with my steel industry background, we're all on board with, if hydrogen can work at scale and cost as is projected, or beyond that, direct electrolysis, for example, in conjunction with biomaterials in the front end as feedstocks, plus some carbon sequestration at the back end, right? Like there's a whole bunch of technologies that kind of work together, we think, for certain industries, and those will actually morph and transition over time. But if we think we're going to flip the entire built universe of industrial facilities in the next 5 to 10 years, I just think we have another thing coming. So we do not think we are extending the lives of those things. In fact, we're looking for facilities that are pretty locked in. Like for steel, they've just relined a blast furnace that's going to last 20 or 25 years, right? They're kind of stuck, right? They don't really have a lot of options. And so, we think we can help those, as well as stranded assets that might not have accessibility to CCS. And then I'll also say, if we only look at carbon capture and geologic sequestration at CCS, that actually could lock in a little bit more of a linear model, right? Where you're still extracting fossil resources, you do something with them, and then you take the carbon and you pump it underground. That's actually linear. What we're talking about is a fully circular, sustainable supply chain.
Okay, thanks for that. So, obviously, one of the reasons I invited you on the show was the implications for the carbon removal industry, right? It's as is true for anybody engaged in point source, right? It's going to be a challenge what we do with the CO2 in BECCS facilities and DAX facilities and so forth. Is Lanza directly engaged with any CDR sector players at this point?
Yeah, the short answer is yes. The even shorter answer is we're under non-disclosure agreements, so I can't talk fully about that.
Fair
But
enough.
absolutely, and it's part of our story. It's part of our transition story, and we want to help that industry get up and running. And as we're looking at project deployment, and this goes beyond the licensing model, right? When we're looking at actually deploying projects with other partners, we are looking at all the parameters. So maybe you have industrial gases, but let's say you don't have additional hydrogen to bring in, or you don't have renewable power nearby, or there's a lot of details around putting these kinds of projects together. So siting is really important. So if we can go somewhere where there are abundant renewable resources, for example, electricity, and we could make hydrogen and we could capture CO2 from the atmosphere, that could be a really perfect solution to making, again, some of these essential products, rather than merely capturing those and storing them underground. And ultimately, if we're skating to where the puck is going to be, that's going to be the long-term solution, right? There will be some amount of waste, agricultural, food wastes, et cetera, that are always going to be around human society. But then, humans use a lot of stuff, and to the extent that we can then use carbon dioxide that we need to pull out of the atmosphere to do that, again, rather than pulling new fossil resources out of the ground, I just think CDR is going to be really important, and first important to go get the carbon out of the atmosphere and pump it underground, okay, and put it into other permanent solutions. Totally on board with that. But we're talking about that sliver of the economy that will still be there, that is going to need waste carbon resources.
Okay. All right. I'm going to ask you one more question and then go to audience questions. Broad question for you. In what has to be, as is true with all startups, a challenging milieu. What do you see as the biggest challenges for scaling up carbon capture and utilization over the course of the next couple of decades?
Yeah, I mean, the biggest challenges, I would really put them into buckets, right? So, and of course, wearing my policy hat, policy is a huge one. If you don't get the policy right on this, it makes it very difficult. We see very different considerations, applications, et cetera, geographically around the world. Some places there's more pressure for carbon emitters to do something, which then is puts us in a position to work with them. Of course, some of those same places are highly regulated, and they have lots of opinions about, oh, this is exactly right, or that's exactly wrong, and so policy can be a double-edged sword. So we obviously want supportive policy, and I mean, as first blush, a price on carbon would be the first thing that would encourage emitting industries to reduce their emissions. And in the US, we don't have that, right? We have the carrot approach, but not the stick. And what I like to say to folks who are very supportive of R&D, innovation, et cetera, those are incredible, and we need those, but they only take you so far. They don't actually deploy the technology. We need people to want to and need to deploy the technology. And so policy is number one. Then you get into the usual suspects of financing, infrastructure, really getting these synergies. And then finally, a higher level one, and I think that as part of our conversation right now, is also sort of the inertia of confusion about where are all those things I just mentioned going? Where is policy going? As a company, people with fiduciary responsibilities, do they bet on an early technology, a startup or something that hasn't been tested, or it's been deployed commercially in a couple facilities, but not in the United States, for example, and getting everything to work right with the IRA and the bipartisan infrastructure law, right, and connecting all the dots, getting the energy transmission infrastructure in place, et cetera. And you have got big emitters making big decisions, and if they make the wrong one, they're like out of business. It's kind of that bad, right? So I think that's ultimately all of that swirl of stuff just doesn't lead to certainty and to making big investment decisions. So we have to tackle all of them.
Good luck with that.
Hey, welcome to my everyday, and probably 90% of the people on this call or more.
Yeah, probably true. All right, so let's move to some of those questions. First question is: are your only inputs CO2 rich gas and bacteria?
So no, it's carbon monoxide, carbon dioxide, and hydrogen in various compositions. So we have to look at industrial gases. We'll look at what the specific composition is and whether we need to bring in additional hydrogen, for example. But to the extent that we get fairly pure CO2 streams, CO2 is inert. So you and I couldn't eat just that, and neither can our bacteria. We would need to feed it additional energy in the form of hydrogen. It tends to like to operate on carbon monoxide, which is why we have targeted things like steel mills, which do have energetic gases still available. But any of those options, gasifying, biomass, et cetera, that's giving us essentially CO2, and hydrogen.
Okay. All right, next question. If the process that's described is possible, especially industrial off-gas capture and conversion, wouldn't this be a more sensible thing to pursue than deep well injection of carbon, which is being pushed by the Department of Energy and other agencies in the United States?
Well, I mean, my general view is we need it all. I mean, you need all of these technologies, and you mentioned earlier in the intro the gigaton question, right? And so, and you also have different regional differences, et cetera. So, I think we need it all, and to get at that scale. I do remember being, a younger Hill staffer and having people come in and explain to me some of the other utilization technologies like baking soda, et cetera. And all I could think of was, we're going to be buried in baking soda, right? If you put it all to one thing, it's just like moderation and balance in life, that won't work. So I do think we need the wide array of solutions, particularly just on that scale question. It's just so massive that it's hard for me to think of ways to only use utilization for all of that waste carbon. We have taken millions of years worth of solar energy that's in biomass that converted to fossil fuels, and we have put it up in the atmosphere in basically a century and a half. And we got to go get that stuff in some way, and avoid new to the atmosphere as much as possible.
Has your company done any back of the envelope calculations of what percentage of this overall process might be utilization as opposed to storage in the future?
Not really, and part of that is just it's really hard to do that. I mean, IEA and others have attempted to do such things, but I'll go back to my regional comments, because both the sort of built environment and the geologic sequestration options, and the nascency or relative development of the countries that we're dealing with, they're all over the map, and so it's really hard to come up with. I mean, there's probably a theoretical answer to that question, but there's also the question of sometimes utilization products can be long-lived as well, right? Concrete and other things, but there's only so much concrete in the world, right? So I don't have a good number for that, but I'll go back to we need to do it all anyway. So, and there's plenty of market to share.
All right, next question, with a bit of an environmental justice overlay. In the conversion of landfill and plastic waste, what are the air quality and quality of life impacts to communities near these facilities that gasify plastic waste?
Yeah, great question. So we're really looking at all aspects of environmental justice and diversity, equity, inclusion, and accessibility, et cetera. That's exactly the question you need to ask when you are actually gasifying something. And one of the challenges, there are many different gasifiers. There are hundreds of different gasifiers. It's not like, Coke and Pepsi are like the two big contenders in gasification world. So you do need to look at that. There are lots of systems for gas cleanup, et cetera, and pollution control. So, but that's the question you need to ask. I mean, I think we would prefer you out of the landfills, you get as much of things that are like plastics that are recyclable, and you do mechanical recycling of those, but then converting through gasification into gases that can be used. The good thing about what we're doing is we have biology in the middle. So rather than additional chemical processes, you're really looking at the biology moving and you're converting those gases into something useful. And then we have wastewater treatment on the back end. So if something has come in through the system, it will be removed as a solid on the back end. But great question, and we are absolutely attuned to that and looking at it closely for projects.
Okay, thanks. Next question. What kind of CO2 capture technology do you use? Is it your own, or do you license or contracted? Any partnerships on the capture side?
I'm glad this person asked this question, because it's different than when we hear the words carbon capture. Those of us working in the space, we usually think about using amines and other things, et cetera, to capture the carbon and concentrate it. With the LanzaTech process, we're talking about like putting a straw in and just feeding off the actual raw gases from the industrial facility. So it's actually, we're taking all of the gases, we're not just getting it down to the carbon dioxide. Now we may need to do some concentrations, et cetera, but overall, in terms of LanzaTech, we're just taking those industrial gases, assuming we've agreed that we looked at those compositions and it has enough energy content, for example, to go into our process. So we don't have to go through those really high energy penalty processes, high heat, temperature gradients, et cetera, and lots of catalyst going in, in chemicals to really concentrate the CO2. So it's a little different than the traditional carbon capture world that we hear about.
Okay.
Great question.
Next question. What's the price difference between current alcohol to jet production versus synthesis from carbon dioxide and hydrogen to jet?
Ooh, okay. Well, I don't have that answer. That's a good economics question. I know essentially all of the sustainable aviation fuels are at a maybe 2 to 3 times jet fuel, petroleum-based jet fuel, but I don't have the depth of numbers to be able to parse out the differences. I would say they're all generally in roughly the same range, and we all sort of lobbied together for the Sustainable Aviation Fuel Blenders Tax Credit, for example, in the Inflation Reduction Act, that sort of thing, where you get $1.25 to $1.75 a gallon to help make up that difference. And really, it's about the competition between the ground transportation fuels, because right now, we're pre-IRA, making renewable diesel made a lot more economic sense, but now we're finally seeing closer to a level playing field. So that, yeah, I'd have to talk to our friends at LanzaJet or others to see if those numbers are knowable right now.
Right, but probably in line with that double or triple metric that we generally look at in that sector, correct?
That's what I've heard. Yes.
Mm-hmm. Okay, thanks for that.
Mm-hmm.
Next question: does it make sense to focus on development of thermochemical pathways such as pyrolysis and hydrothermal liquefaction over oleochemical pathways for production of fuels?
There are probably 100 people at LanzaTech much better suited for me than me to answer that. That's deep in the chemistry. So I'm going to have to take a pass on that one. I'm happy to be in touch with whoever's asking that, but that's a little too chemistry, not my political science side.
Okay.
Thank you.
That person's denominated as anonymous attendee, but if anonymous attendee wants to drop us a line, we'll pass it on to to Tom to pass it on to some of the folks there for a response. Next question. Are feedstocks like municipal solid waste used to produce jet fuel? From what I understand, only bioethanol from cooking oil can be used to mix up to 50% blend with fossil jet fuels.
So there are essentially 7 ASTM approved pathways for SAF. The reason we think about the sort of fats, oils, and greases, the FOGs, or HEFA feedstocks, is because those are the most readily available. So yes, those are the ones that are being used early. But what I'd call second generation SAF technology, like the alcohol to jet technology that we have spun out to LanzaTech, those can absolutely use all the waste that I talked about before, or including industrial. But yeah, MSW or biogenic waste from biomass, from landfill gas. There's a lot of different pathways to get there that have been approved for this 50% blend, essentially into Jet A, which all SAF is able to be blended at 50% at this point, and the OEMs, et cetera, are working on getting that up to 100%. I mean, my CEO flew on a flight from United from Chicago to Washington, where one of the engines was on 100% SAF, and so we trust that it works.
Okay. All right. Next question. Where is the green premium the lowest for products made with LanzaTech process?
Where is the green premium the lowest? Oh gosh. Yeah, I'd say the green premium is all over the map, and so I go back to it's partly regional, which country you're in, how much pressure each sector is under, and then within sectors, right? Some manufacturing facilities. I mean, take the EU ETS for example. Right. Some sectors have been in for a long time, others aren't. Some are upstream products, some are downstream consumer products, which sometimes are laggards in terms of if they're going to have direct regulation. It's more upstream at the sort of basic chemical and material level. So I don't know that there's really an answer to that question. I mean, we certainly see more and less developed markets. I mean, obviously the EU is a highly developed market. They've had a regulatory scheme for quite some time. The US is behind that. Obviously, lots of us were working on trying to do economy-wide, cap and trade, over a decade ago. Didn't happen, right? So we're even our two relatively similarly developed regions are quite different. And then you have India, for example. We're doing a lot of work in India, but they're really pushing for a fuels policy. I mean, they're still bringing energy and clean water to their over 1 billion people, right? So I think you really have to parse it out. There's no blanket answer to that question. It really depends on the sector. And you see some of the early deployments that we've done in fragrances, in cleaners, in fabrics, for consumer-facing brands. So some of these that are more iconic, more recognizable. But where we're going and what we're trying to do is make sure that we actually get that premium lowered so that there's more accessibility of lower carbon products for everybody, for all people, and not just in fully developed economies. When we're talking about India, China, Africa, all around the world, and even in the United States and other developed economies, we think you should be able to go, buy strawberries that are packaged in a sustainable package, not only some of the higher end consumer goods, but those are some of the places that just makes a lot of sense to start in.
Next question. What about non-carbon dioxide aviation emissions?
Yeah, great question. Well, this is actually one of the benefits and advantages of moving to sustainable aviation fuel. We don't use that word sustainable lightly, and we don't mean it only to mean greenhouse gases. There's a lot of work being done on looking at contrail reduction, because there is contrail reduction. Now, the exact effect of that on climate is being studied, so you don't want to be definitive about that. But if you look at particulate matter, et cetera, there are essentially no aromatics in SAF, so it is actually much lower polluting. So I really think about get back to the environmental justice questions, is about what airports look like. if those planes on the ground are you're burning SAF, there's hardly any air pollution from that. So there are actually amazing reductions, and there's also a higher energy density to SAF, so you can use less of the fuel itself as well. So there's some really incredible non-CO2 emissions benefits from using SAF.
Okay.
And that's basically all SAF, not just the kind that we work with alcohol to jet.
Right. All right. Let's see. What percentage of carbon dioxide that's captured is utilized in products such as fuels or chemicals?
That's going to be very case specific. And for us, it's about how much energy we can bring to the CO2. So if we can bring enough hydrogen, we can get essentially close to 100% carbon efficiency, which is bringing that, is embedding that carbon into those products. To the extent that we go less than that, then we would just get less abatement than would otherwise be the case. So you can get up to close to 100% CO2 conversion into products, but again, it's going to depend on the product. It's going to depend on the system you're using and what you're bringing to it.
Okay.
So for us, that means CO2 and hydrogen, basically.
Okay. Speaking of hydrogen, this is a question I had also, so I'm glad to see it teed up here. It says, from what you've told us, your energy source is hydrogen. What color hydrogen are you using? If green, does that rule out certain locations, such as without wind or solar? Do you have to say no to some steel plants?
So hydrogen is important for us. It's not the only energy source, though. So if we get carbon monoxide, that has carbon and energy. So that's the first thing we want. So, but then if you do go to pure CO2, we need hydrogen. We are color agnostic. We want low carbon hydrogen, and we want it as low as possible. And green is ideal, right? Green, or if you want to say pink for nuclear. I mean, zero carbon hydrogen is what we want. And it matters too. I mean, the life cycle of, we will use so much hydrogen that if there's any blip on the life cycle screen, that will be a problem for our overall life cycle emission story. And so that could, if we were to use higher carbon hydrogen, it just wouldn't make a project make sense, because LanzaTech is not in the business of just making stuff with waste carbon. We're in the business of reducing global climate change. Okay, so that's a very important pillar of it. That's like why we exist, is to improve climate change. If we don't actually improve the climate situation, then that's not something we're seeking. So we have to make that life cycle work.
Right. So does that really constrain you, given the fact that there's a very small percentage of hydrogen that's being made with green hydrogen at this point, right? Does that really constrain the operations that you can engage with and ultimately claim from a life cycle assessment that there's a substantial reduction in CO2 emissions?
Well, first I'll say there is some low-hanging fruit. So to the extent that we find emissions from industrial facilities that have carbon monoxide, have energy already, or some of them actually also have hydrogen just as a part of their process. So they might have CO2 and hydrogen in various ratios. So I'd say every ton of carbon we can abate is a good ton to abate. And then getting to nearer to perfection will absolutely require the build out of the clean hydrogen industry, and so we're very supportive of that. So yeah, I mean it's a limiting factor, as there are lots of limiting factors though to all of this, right? Back to my talking about projects and how we put them together. You also need enough clean electrons to make that hydrogen, and if you're doing it with electrolysis, you need enough water to do that. And if you're either moving electrons or you're moving hydrogen, unless you're doing it all on site, which lots of concentric circles that you kind of have to work through. And it's not just a LanzaTech challenge, right? This is a societal challenge that we're all trying to work through. But again, we're trying to find highest best uses of that waste carbon, and think we need to get started today. So even if there's a project that's not perfect, if it's really good, we'd like to do that. do that project. And then over time, as that infrastructure develops, it just gets better and better for us, more impactful.
Okay. Next question. This is a question related to carbon accounting. In order to count or realize reduction or removal in corporate inventories, does Lanza have to get a credit verifier involved? In other words, does this technology enable selling offsets, or do your corporate clients just aim to reduce their Scope 1 emissions?
I actually haven't been close enough to some of our specific deals with customers to really be able to answer this question well. But there are certainly cases where we would need a third-party verifier. And then certainly with some of the government programs, that's a requirement. 45Q is an example. Carbon utilization is the only part of, and by non-enhanced oil recovery, carbon utilization is the only area within 45Q that requires life cycle analysis at all. And we have to prove sequestration into a product or displacement of fossil fuels in that final product by making that final product. So, and those require third-party verification as well. So I think it's really company by company how they're doing this. I think it will solidify over time. But I've had lots of discussions over the years in this job and others, about how consumer-facing brands and others who have made those commitments, how are they going to meet them? And I do think that's kind of a company by company answer at this point.
Are you you or the companies that you're working with heavily engaged in the 45Q process at this point? What role do you play?
Yeah. I mean, we've been heavily engaged in 45Q for quite some time. And when LanzaTech was working with me and with my previous company, steel company in the U.S., we worked to actually change the definitions of the 2018 45Q update to include carbon oxides, not just carbon dioxide, to make sure that you don't have carbon monoxide out there that has to be transferred into CO2, right? You have to under EPA destruction requirements, you have to flare it basically. And so we thought that was a really bad idea if you could capture it and use it for something. So we've been heavily engaged in that. We were heavily engaged in the IRA, and of course are following very closely the IRS Treasury guidance as well around the program.
Okay. All right. Next questions. Which of the precursors you are making has the most potential to scale to gigatons of carbon removal annually?
Well, I mean, I would start with the ethanol that we're making. I mean, that in many cases that can replace the fossil carbon that is going into the petrochemical refining industry. So that's a huge swath of emissions across the economy. So that's a huge one. And then it's almost subsets of that to some extent. If we can get to a particular chemical by skipping processes, so instead of inserting ethanol into the existing supply chain, which could still include some other emitting, not greenhouse gas, but there's some really hazardous processes that the chemical refining industry has to go through. If we can skip those and use biology to go directly to those, like MEG we were talking about before, and skip some of these more polluting vectors, then that's really going to be a big win as well. And again, beyond just the CO2. But I would say, yeah, making ethanol and making those chemicals that today come from fossil fuels, that's a huge market.
Okay. All right. We're going to move to intellectual property rights. Is it possible to patent microbes? How does this work?
Yeah, we have, at this point, I think we have over 1,250 patents, and usually over 500 pending. So IP is the name of the game for us, a very important part of our business portfolio. And we are patenting not just the specific biology. I don't know the specific answer to the question, whether we can patent a microbe specifically, but I think we can patent the method by which we have produced that microbe, doing a lot of synthetic biology, and how the biology works with the engineering and the chemistry. there's a lot of processes that are going on here that we have a lot of expertise in, and really, on the cutting edge of those, and using artificial intelligence, for example, characterizing how organisms will react to different concentrations of gases, and also working with different biocatalysts, and essentially like the vitamins and the enzymes and the things that you would work with the biology to make it work. So really interesting area. I do have experts that could talk much deeper on that, but yeah, IP is critical to our industry.
How much carbon monoxide versus carbon dioxide does your process need? Can it run on just carbon dioxide plus hydrogen?
I mean, I think the short answer is yes. But what happens biologically is that the organism will actually split carbon dioxide back into carbon monoxide. So it does like CO.
Right.
But I think we're working on that. But obviously, we're starting with carbon monoxide concentrations, and then adding in additional CO2 and hydrogen on top of that is sort of the preference. But I think from a technical perspective, you can get there, or you can take CO2 and you can run that through an electrolyzer and convert that to CO as well. The bug does like CO. That's its favorite. It's its favorite food. It's like ice cream.
I've never heard carbon monoxide compared to ice cream before, so that is a first. All right, let's see. What expertise is required on site to operate your process? Does it require lots of maintenance or expert babysitting? Can it scale down to smaller sites where appropriate gases are generated by some process?
Yeah, great question. Actually, I think of this also in the context of the energy transition, because these are small biorefineries. It's a lot of valves to be turned. It's but it's not it's not something, we don't need a bunch of PhDs running around doing this. This is really blue collar jobs. You might have an engineer on site, et cetera. But no, these are great. And in fact, this question about scaling down, right? Most people ask us about scaling up, but we are really interested in finding the right scale. And that is mostly driven, I think, as the questioner was sort of insinuating, on feedstock, right? So you want to be able to put these, and the units right now are modular. I mean, some of these facilities, like the ArcelorMittal Ghent facility, which was just commissioned in December, has 4 bioreactors. And so you can put these in train. You could put a whole lot of them, or you can put fewer. I think where the rubber meets the road is really about economics of that. It's how big does it need to be with that given feedstock, at what cost, and with which utilities? Because once you build this, you've got to build in to make sure you have enough power, and the other utilities that need to come in. Maybe they're already existing there. So that all gets around really to project economics, and how much does it take? How much production do you need to make enough money by selling that product to to essentially pay off the financing for the facility.
Mm-hmm. You probably don't know because you don't have a lot of experience with it, but do you think that would create any constraints in terms of smaller DAC or BEX facilities, for example? I mean, what scale do these have to be to cost out?
I don't think so. Well, okay, yeah. I mean, everything's relative, right? So if you get 1,000 ton a year facility, that's not going to make enough. That's not going to make enough product, right? So I think we're really looking at probably 100,000 tons of CO2 a year or more would probably be kind of in the sweet spot in terms of coupling that with hydrogen and gas fermentation.
Okay, that's helpful. All right, I think we have time for one more question, and we always have a question on biochar, so I'm glad we had one in here. So it's kind of a hallmark of the series. So the question is, biochar production is always accompanied by syngas, carbon monoxide, and hydrogen. Could LanzaTech work with biochar companies?
Yes. Yeah, sure. Short answer, absolutely. And by the way, if we are using gasification technology, we could also have biochar availability. So we're interested in that as well, and looking at the applications for better uptake of soil, of CO2 in soils, and other applications of actual biochar. So that's of interest to us, not just as a potential syngas provider, but also as an end product. And I didn't even talk about the fact that we also get a protein with our bacteria. It has an end of life, and it is a high protein source. So, for example, at our China facilities, we're able to take that and use that as feed for chickens, for fish, you name it. So that's another opportunity to really get as much of that value and carbon into the system as possible.
All right. That is a good place to stop. We are at the top of the hour. So I would first of all like to thank Tom for coming on the show and telling us about this this fascinating process, which, as I said, will ultimately have a lot of implications for the CDR industry as we look at this mix of utilization and storage, and what will be the optimal balance thereof is going to be heavily influenced by what utilization opportunities we have, risks, and so forth. So I really appreciate that discussion, and thanks to everyone that asked questions. I think that really helped flesh these things out. And with that, I will close the show. I hope you'll join us for future episodes. We'll be back on in about 2 weeks. And I hope everyone has a great rest of their day or evening. Goodbye now.
Thank you.